Okay, so I guess let's get started. It's about 2:10. So as you might have noticed, Brian's not here today. I'm Eric, one of the TAs. We'll be lecturing today in place of him, and then Darren will come in a bit. So a couple announcements. Recall midterm 2s tonight. Hopefully all of you know. It's from 7 to 9 p.m., 2050 VLSB, same place as last time. So remember that there's no group portion for this midterm, so you don't have to coordinate with your groups before the exam. Okay, so recall that last lecture Brian left off talking about the environment model of evaluation, which we're covering today. And I find if we're going to learn something called the environment model, we might as well define what an environment is. So an environment is just two things. One, a frame. And a frame, a frame just, it basically is a binding from symbols to values. So it's just like a variable list. So we could represent this as, let's say we had a variable foo and a variable x defined in our current environment. We could show this as like foo mapping to, let's say it has value 42. And then the variable x, let's say it has value 2. So this is what the frame would kind of look like. High level, foo maps to 42, x maps to 2. And then, in addition to the frame, an environment consists of so it also contains a pointer to like an enclosing environment, also like a parent environment. We'll get into what exactly this is a bit later, but just remember these two facts about what an environment are. Okay, so let's talk about, it's actually kind of helpful to think about the environment model related to the substitution model. So it's kind of remarkable how similar the two are. Okay. So in the substitution model, so when we're doing a procedure invocation, recall that in the substitution model, we first have to evaluate all of the sub-expressions. So it's like evaluate the operator and evaluate the arguments. And as Brian said, this is still true in the environment model. So after we evaluate the sub-expressions, the next step we want to do is we want to apply the procedure to the arguments. And this is still true in the environment model. So far, everything's exactly the same. But the way they differ is right here. The way the substitution model applies a function to an argument is we call that kind of nasty function called substitute, where we substitute all formal parameters with its given value. So substitute, how do you say, arg values for the formal params. And then here's this important next step. We evaluate the modified body with all of the formal parameters substituted in for values that we've given it. Eval modified body. Great. So this hopefully looks familiar. This is what scheme 1 did. So now we're learning about this new guy. And now when we apply procedure to, when we apply a procedure to arguments, we're going to do something else. So we're going to make a new environment and have the formal parameters of the procedure bound to the values we give it. Okay? And then the next step we do is so now we evaluate the body of the procedure, but within this new environment we just created. And I'm running out of room, sorry. So to compare and contrast the two, let's go through an example. Using a substitution model, let's say we're evaluating this. Lambda of x, and I don't know, let's just add to it, plus 1x. And we invoke it with an argument 4. Substitution model says evaluate all the sub-expressions. This is a lambda, so it's self-evaluating in scheme 1. A number is also self-evaluating, so it evaluates to 4. Then we call substitute 4 into every instance of x in the body. So we end up doing plus 1, 4, which yields 5. Nothing crazy here. But things start to break down when we have something that looks like this. So let's say I have this procedure foo that just set bangs its given parameter by and increments it by 1. If we try to evaluate this call foo of 4 in the substitution model, something funny happens. Because we'll do exactly what we did before and just substitute 4 in for every instance of n. And then we get something weird. We get set bang 4 to be plus 1, 4. This is kind of strange. And this is why the substitution model is no longer sufficient for our needs in this class. It fails at trying to do setbang. So yes. But then let's contrast this with what the environment model does now. If we invoke foo of 4, so bear with me. I'm creating first the global environment. We'll define this in a bit. But just think of this as the environment that you're using when you're typing at the SDK interpreter. When we invoke foo, we create a new environment, just like this says. I'll call it E1. And then we bind the formal parameters to the arguments we give it. What are the formal parameters of foo? Well, it's n. So we write an n. And what value did we give n? We gave it 4. So we write 4. And then we say, OK, now evaluate the body of the procedure relative to this new environment. So setbang n plus 1n. So we find an n, and we increment it by 1. Hooray, we did the right thing. But notice that this is kind of suggesting that all evaluations are done with respect to some environment. And this is always the case. In the environment model evaluation, you're always evaluating something relative to some environment. It doesn't make sense to try to eval something without giving an environment. So as Brian says, you can't eval in a vacuum. You have to do it in some environment. So let's start up a list of facts. Okay. So I've kind of used this thing called the global environment, so let's kind of formally define it right now. So the question is, what is this global environment? And part of answering this question is asking, what should be inside the global environment? So when you think of like when you're using the terminal, like on the lab machines, and you're just kind of typing away at Scheme, what kind of things do you expect to be inside the environment already? Yeah, I heard primitives, and that's great. So stuff like plus. Actually, this is too small. So you notice on day one that you could already use stuff like plus or times or first or rest or coder or car. Actually, not coder or car, first and rest. So in reality, you can think, if you'd like, that the global environment has all of this stuff. Plus maps to recall that this is what procedure looks like in STK. So we have a binding from plus, the symbol plus, to a procedure. We have multiplication already bound to its own procedure. We have first bound to its own procedure. Not really writing. And so on and so forth for every single primitive that you can think of in STK. You can imagine that writing all of these can be really tedious if you had to do it each time. So you can omit these when you're drawing your own environment diagrams. But conceptually, realize that these are there. They're just implicit, because they're built-in primitives to STK. So as I said before, the global environment, it's pre-installed with all these primitives. So if all evaluations are done in some environment, that implies eval, like the function header now looks something like this. Take some expression and an environment in which to evaluate the expression in. Okay. Any questions so far before I move on? Okay. So we've just defined what environments are so far. Now we have to ask when are environments actually created. And it turns out we only create a new environment whenever we invoke a new function. So create a new environment when you invoke a procedure. And in this class, after 7 odd weeks, whenever you think of procedure or function, you think of, yeah, lambda. So naturally, let's proceed to how lambdas are treated. What can I erase? I guess I can just erase this. Okay. So this next part, it's going to sound a little weird at first, but just kind of bear with me. It'll make sense why I'm doing this. So in this new model, we're going to represent a lambda as these two bubbles. Okay. Let's see. Okay. So say I defined a lambda in the global environment called foo. So if I wanted to draw the environment at this point, we have a new symbol foo that's bound to something. Oh, okay. This box is too big now. And this thing is a lambda. And in the environment model, a lambda evaluates to this funny looking thing. These two bubbles, where the left bubble represents the actual lambda expression. So it contains the parameters. Here's just x. And the body, which is multiply x by x. And then this right bubble, these lambdas are going to remember where they were born, like where they were created in. So because this lambda was created in the global environment, this right bubble will point to the global environment. Why we did this will be clear in about 10 minutes. But anyways, so let's say we actually invoke foo now. We say foo of 4, a nice number. Let's refer back to these rules. So remember, we're in the environment model. So if we're evaluating this function call, we're going to evaluate the sub-expressions, easy. Then we apply the procedure to the arguments. And that involves, we create a new environment. And we're binding the formal parameter x to the value we passed in, which is 4. And then we can evaluate x times x within this environment, which yields, as expected, 16. So that was a fairly procedural process you guys will all learn how to do. Yes, question?
Is that bubble that you drew for lambda, is that supposed to be in the environment or outside?
You can think of it in. Oh, you're right. I forgot to draw this arrow. Foo points to this lambda. Yeah. Yep. Yes. Oh, right here. Yeah. Could you repeat that question? The environment in it's actually the inside parentheses, the +1n. Not quite. It's not that this environment is contained in here. It's rather that this expression is being evaluated within this environment.
But wouldn't that be just setting 4 to equal to 5?
Yes, and here, that's what it would try to do in the substitution model. But this is the environment model, where we created this new environment, we set n to 4, and then we just say setbang n to be +1n. So following just the regular stuff, we say setbang n to be 1 plus 4 is 5. So, yeah. Okie doke. So back here. So some of you might have noticed a slight problem. Remember that I said all the primitives were only defined in the global environment. I did not say that when we create a new environment that they're kind of copied over. So right now, this environment, if I try to evaluate times xx, we do find an x binding, but we don't find a multiplication binding. So then the question is this is problematic. We don't want an unbound variable times when it's clearly defined in the global. So what we intend is we want everything that's visible in the global environment to be also usable in any environments we create. So how do we show this relationship in these diagrams? Remember when I defined an environment, I said an environment's two things. One, it's a frame that binds variables to values, or symbols to values. And two, it's that pointer that points to another environment. Right now, I have the frame. X is bound to 4. But I don't have that pointer yet. And I'm going to show that relationship. I'm going to draw this pointer to represent that this environment is enclosed by this environment. So what this means now is when I do variable lookups, we do the following. I'm trying to find the symbol times. If I don't find it in my current environment, I ask my parent environment to see if my parent has that variable. So here, no times. So I look in the global environment, and yep, there's a times in here. So we return it, and we know how to do multiplication in the child environments. Right. So actually, I should probably write down those rules if I have another board. Okay, so if I'm trying to find the variable, look up the value of variable foo, the first thing I do is I'll look in my current environment. If I find it, like here, trivially, n is already in the environment, great, I can return it and I'm done. If found, return it. But if I don't find it in the current environment, then it's not, all hope isn't lost. I just look at the parent environment. Okay. So it's exactly what you've kind of intuitively known. If you don't find a variable in your current scope in your procedure body, you've known that you can look in the global environment also. But what happens? So you can imagine you can have multiple chained environments together linked, but if I'm trying to find a variable at the end of the chain, what happens if it goes all the way to the global environment, but it doesn't find it in the global environment? What should it do? Yeah, it should throw an unbound variable error, because if it didn't find it in even the global environment, that means it's just not visible. So we say if So we only reach this third case if we've reached the global environment. We don't find the variable, then we throw unbound variable error. So the final question we want to ask is, I didn't really justify why I had E1 point to the global. Here it's kind of obvious it has to point to the global because it's the only other choice. But you can imagine a more complicated scenario where we have, I don't know, let's see. Oops. Define Wait, what do I want? Okay, so say I have these procedures defined, procedure foo and bar, and then name defined the global scope. And then I call foo with argument Darren. Well, we're going to draw the global environment as always, where we have name. This chalk is name, bound to Eric. We have foo and bar. And foo is this lambda that takes in a name, right? Yes. And its body is to call bar with arg, or name. So enough room. So foo points to this lambda, and then bar is going to point to this lambda. This is the one that has an arg, and I'll spare the body. This remembers it came from here. So understand why that these lambdas point to the global environment. It's because they were created in the global environment. Kind of like I just typed them at the terminal. Okay, so I say foo Darren. We're doing a procedure call, so we create a new environment. With the formal parameter name bound to whatever we pass in this case it's Darren. And we'll just say that this points to the global environment at the moment. But then we're going to call bar while we're inside this environment. I'll write it here. So I'll call this new environment E2. It's the environment created by invoking bar. Here, arg is also Darren. So then here's a big question. The body of this E2 is setbang name to be arg. Which environment do I have E2 extend? Do I extend the global environment, or do I extend E1? Yeah, I heard an E1, but you, so this brings up kind of a design choice. There's really two cases for deciding which environment you need to extend. So one way you could do it is you could have your language always extend the lambda's environment. So in this case, we would have E2 extend not E1, but the global, because this environment is associated with this lambda, and this lambda says I was born in the global. So if I did that, then we will do this. We will say set bang name to be arg. We try to find name within the current environment, and we don't find it. Following those rules up there, we go to the global, the parent environment. We find name in the global. We set bang Eric to be Darren. Great. This is exactly like, this shouldn't be any surprise because this is what Scheme does. So actually, I'll write that down. And this happens to be called lexical scoping. And I guess I'm a little biased, but I like to think that this is the sane way of doing things. You'll see that trying to do it the other way leads to code that's just kind of crazy to follow. But it is there, so let's talk about it. Let's consider the other option. What if we always extended the current environment? Well, this picture now changes. This arrow, E2, does no longer extend the global. And instead, now E2 is going to extend E1 because our current environment was E1 when we invoked bar. And I misplaced chalk. OK. So if we have this picture now, things start acting a little funny. I say set bang name to be Darren. I don't find name here, but I find it here. So I change this to be Darren. Doesn't really do much here. And then that's it. So then at the end, name is still Eric in the global environment, which kind of looks weird. So, but that's what dynamic scope does. And it's a valid choice, I guess. For project 4, you'll actually be working with a language that does do dynamic scoping, Logo. But most languages do use lexical scoping. So, yeah, any questions before I hand it off to Darren? Yep.
What exactly does extend mean?
Extend means, so if E2 is extending environment E1, that means that if I don't find a variable in here, I'm going to look in here. So that's, yeah. Yep. You can, in this case, they'll still be there. You'll never be able to reach it again. But in the next lecture, or actually what Darren's going to talk about is when environments do persist. And then we can use them for some pretty cool features. So, yeah. OK, so hand it off to Darren. Oop.
Can you hear me? No, kind of. Oh, I don't need it. Can you hear me now? Still pretty bad. Good? All right. So Eric talked all the way up till set bang. Let me clarify a little bit up here. Someone asked if we could see or just think that this lambda belongs in this frame. You shouldn't think that because you should think this bubble just exists somewhere and then we have references that point to it. Because you could later have code like let's say function f takes a function g and x some value and applies g to x. And later we call f foo on 3, something. So expect this to give us 9, right? On the diagram, we will see that, all right, I guess this is a bad color, but right, so f will point to a pair of bubbles because when we define a function, we draw two bubbles. Points here. Parameter is g and x. And the body is apply g onto x. And when we make this call, we will have a new frame. So let's draw a new frame here. E2. This frame is associated with this lambda, right? Oh, forgot to point this. So inside there should initially be two bindings, g and x. G will be the function foo, x will be 3. So now g is foo, right? What foo holds. So what foo holds is a lambda. So here we could point like this, right? So that's why you shouldn't think that these bubbles belong in this frame, right? Because if it's basically variables pointing to a construct of lambda, and any frame could have references that point to those two bubbles. So I just hope to clarify that. Okay, so Eric introduced setbang, or probably Brian did. Setbang, what it does is it looks for the closest variable with the variable name, and then set it to arguments, right? So we can think of setbang as a lookup plus a assignment. Yes?
But in that case, wouldn't if the value of g, like not the value, if g is assigned to foo, wouldn't by the variable lookup, when they go back to the global environment and find foo and point to the global?
Right.
Isn't that assuming that you have foo defined in V2 if it's going to point directly to the global?
It's no. So inside E2, we only have two things, right? We only have g and x.
Right.
We won't have foo in there.
Right. So then by the variable lookup, you have to look up foo in the global variable if you're using lexical scope.
Right. So sorry, I forgot to point this frame. Right. Because
Point directly to the bubble.
it would point directly to the bubble. Yes. Right. Because of applicative order, right? Applicative order, we evaluate your arguments before you go into the body. So when we draw the frame, foo already got turned into this lambda. So it won't point to like the foo name and then look up foo. Okay. Why? Sorry. All right, so you should view setbang as a lookup plus a assignment or change. And by what Eric wrote over there, setbang, if we view it as a variable lookup, you'll look through the frames and then look for the closest variable to set, right? So maybe some of you might have a question of what's the difference between setbang and define? Right, setbang looks through to find the closest thing, and define essentially just, so here if we change this to define, we won't have any lookups. It will just create a new binding here and point it to Darren instead of looking for the closest variable. So let me repeat again. Distinction between define and setbang. Define is very lazy. You don't do any lookup. You don't care. You're never get an unbound variable, right? Because you're defining the variable. You'll just define this new binding inside your current frame and just write down the value. For setbang, you'll look for the closest variable and set it to a new value. So setbang doesn't create new bindings. It changes them. Okay. So one thing to check is whenever you evaluate a define, you should not find yourself trying to look for like, where's the closest guy or changing stuff. You should just write it down. And of course, if there's already a name binding, you just supersede that. Just cross it out and write a new one. Questions? Yeah.
Can I ask a question going back to his point? If that lambda expression was inside the global, right? If I have a pointer back to the global,
Uh-huh.
then just like primitives can be taken from the global in a slide,
Okay.
it still imply the lambda expression. So then why does it have to be outside?
So we don't. Okay, so this is more like a evaluating like order matter, because if you are you saying that we could keep this as g points to foo and then later look it up?
I'm saying that the two bubbles of the lambda doesn't have to, you said we shouldn't think of them as inside the environment.
Right.
I'm saying if we thought of them as inside the
Mm-hmm.
environment, then it would be a similar case to the primitive procedures. And since there is a pointer of the entire environment to the global, we can go to the global and we can look up the procedure and it's there, and then we can use that. Just as we do it.
Okay, so primitives, you shouldn't think of them as inside the frame either, right? When Eric drew the global with plus and minus and this and so on, these are, you can think of them as all lambdas. And so on. They still take this form. Yeah. I mean, it might make more sense if it's inside the frame for you, but it's like this convention that we all use, so we want to stick to it. All right, cool. So any questions on set, bang, and define? All right, let's move on to global and local states. So okay, so I'm going to introduce a make count procedure that creates a counter. See if we have time to finish this today. Oh. Okay, so this make count is a function, right? Does everyone agree? So the main part is like right here, right? definition of make count starts here. The reason why I say it starts here is because when we define this, we know from midterm 1, let turns into a lambda creation and also a lambda evaluation, right? Because we can write let into like this form, globe or something, and so on, right? So it becomes making lambda and calling it right away. So essentially, after we're done defining make count is just this lambda and everything inside. So looking at this, we can see that this part is executed once. And then later, if we do count 1, I will get the result from evaluating the rest. So just looking at this code, can someone tell me what count 1 is going to be like? The second lambda expression, right? Right, and what does this look like? Some procedure, some huge complex procedure that takes in some message, and depending on what the message is, it'll do something, right? So we should all know the name for this by now.